Hello everyone and a very warm welcome to this video lecture series in which we are talking about neural networks and deep learning. And it's really very great to have you all here in this video lecture series. So now in my previous video lecture, we have already seen what the derivative is, and we have used a very basic function to find about a derivative of a function. That is basically, by derivative we mean the slope of a function. So what we have seen in the previous lecture is we have taken into consideration a very simple function that is in the form of a straight line. So our function was f of a equals to 3 times of a. So the slope of the function came out to be 3. Okay, so now in this video lecture we will take into consideration some very advanced functions. uh, Now in the previous video lecture, the function was in such a way that the slope of the function was constant all over the function. Okay, so if you take any point on that function, the slope was constant. But in this video lecture, what we are going to we are going to see is that we are going to take a function, and the slope of the function now in this function would not be constant at each and every point. So the basically the slope would be variable in this function. Okay, so let us take this example in order to have a better understanding. So in this video lecture also we are gaining the intuition about derivatives, and this is the function that we are taking into consideration. So the function is f of a equals to a square. Okay, so this is a quadratic function. And now suppose we take some random values of a. So suppose we take the value of a equal to 2, and at this point a equal to 2, we need to find the derivative of this function, that is the slope of this function at point a equal to 2. Now if I apply a equal to 2 in this function, so what we will be our output. Our output will be f of a equal to a square, that is 2 square, which is equals to 4. So now let's mark this point on this graph. So if we take the value of a equal to 2, and if y-axis represents the function output, that is f of a, so this will be my output. Okay, so it will output a square, that is equal to 4. And now suppose that if I increment this value a by a very infinitesimal small amount, so this will be 2.001 suppose. Although this is a very large increment as considered to the derivative topic, but the increment can also be in the form of 0.00000001. And actually this is only the increment that we should consider. Otherwise this is the very large increment, but for simplifying this example I am taking this much increment. Okay, so now what will be the output f of a corresponding to a value of 2.001? It will be 4.004. So now plot this point also, that is if it is 2.001. Okay, now the points that I'm taking into consideration are not according to the scale. So this is only for showing better visualization. So what will be our output? It would be 4.004. Okay, so now what we have done in the previous video lecture, we have drawn a triangle here. The similar thing we are going to do here also. So we are basically drawing a triangle. Okay, and now we want to find the slope of this line. Okay, that will be the slope of the curve at point a equal to 2. So now in the previous video lecture what we have seen, that in the slope the slope of this curve would be of the form of height upon width. So what will be my height? Height will be, this will be my height upon width. Okay, and change in height, basically this is change in height, or it can be represented as delta of height upon delta of width. So change in height would be represented as d upon d of a of f of a. So this would be my change in height, and change in height would be 0.004 upon 0.001, and that would be equal to 4. So slope would be equal to 4 at a equal to 2. Now suppose that we take another point as a equal to 5. Okay, and we need to find the slope of this curve at a equal to 5. And for a equal to 5, what we have, f of a equal to 5 square, that is equal to 25. Okay, and suppose that I increment this point a to a very small value, by a very small value, that is 5.001. So corresponding to 5.001, my value of f of a would be 25.010. Okay, so now my value of f of a is 25.001. Okay, so what my slope will be? My slope will be d of a f of a. So how much my height has changed with respect to the width? Okay, so that would be the slope. So the slope came out to be 10. Okay, so now when, and the slope of this curve is 10 when we have the value of a as 5. Okay, so now basically when we are solving the calculus and when we are trying to find the slope of any curve with the help of calculus, so the slope is basically taken out as d of a f of a, and this slope is basically the derivative. So we need to find the derivative of function f of a with respect to a. So here a is variable, so if I have function f of a equals to a square, so the derivative of this function would be equal to 2a. Okay, so if I put a point a equal to 5, then the slope of this function would be 2 into 5, that is equal to 10. And if I put a point a equal to 2, so it would be 2 into 2 equals to 4. So you can see the slopes 4 and 10, and that were only my slopes that I have calculated manually, that is 4 and 10 here. Okay, 4 and 10. Okay, so this is one of the way in which you can find the slope of any function. And one thing to notice here, that in this function f of a equals to a square, the slope of the curve is not at all constant. Okay, the slope is varying if you change the point. If you have point a equal to 2, then slope of this function came out to be 4. And if you have another point, that is if you consider the point a equal to 5, then the slope of this curve came out to be 10. And the formula for calculating the slope is that we need to find the derivative of any function with respect to the variable, and the first derivative would give the slope of the function at any point. Okay, so now let us continue. Now let us see some more examples. So what we have seen in the previous example is that if we have a function f of a equal to a square, and when we finally found out the derivative of this function f of a, so the derivative came out to be 2a. And so if the initial points were 2, so f of a was 4 in this case. And if we had a small incrementation to this initial value, that is 2.001, so f of a was 4.004, and the slope came out to be in the form of 2a. Okay, so if you have a value of 2, the slope came out to be 2 into 2, even that is equal to 4. Now suppose that you have another function of the form f of a equal to a cube. Now how you are going to find the slope of this function? You are going to apply the knowledge in the similar way. You need to find the derivative of this function first. So the derivative of this function will be d of a cube. So this will be 3a square. Okay, so suppose that if I take initial value of a equal to 2, then f of a would be equal to 8, because it's 2 cube and that is equal to 8. Now if I increment this value by a very small amount, that is 2.001, so f of a came out to be approximately equal to 8.012. And now if I want to find the slope of this function, I can put the value of a here, So slope would be 3 into, what is the value of a? 2 square, that is equals to 3 into 4, that is equal to 12. So the slope came out to be 12 in this case when the function f of a is a cube. Okay, now let us take somewhat a complicated function than those functions. So f of a is now log of a to the base e. Okay, so here one thing to consider is that we having the base e and not 10. Okay, so this can also be represented as ln of a, ln a. Okay, so this in this form it can also be represented. Now if you want to find the slope of this function, then find the first derivative of this function. So the first derivative of this function would be d of a of f of a equals to 1 upon a. So this would be derivative of this function. And here also, if I suppose take the initial value as a equal to 2, then f of a would be log of 2 to the base e, and that would come out to be 0.69315. This is somewhat an approximate value. And if I do a small incrementation to this value, suppose a equal to 2.001, then f of a would be equal to 0.69365. These are the approximate value. So let's put a tilted equal to. Okay, and now if I want to find the slope of this function, I can directly put the value of a here. So the slope would be 1 upon a, that is equals to 1 upon 2, that is equal to 0.5. So the slope of this function at a point a equal to 2 would be 0.5 or 1 upon 2. So these are the very simple ways in which you can find the slope of any function, or you can find the derivative of any function at a particular specific point. Okay, I hope this concept is very much clear to you. If this concept is not clear, or you have any doubt regarding my video lectures, then you can post it in the comment section below, or there is one Google form given to you in the description of this section, so you can also fill your personal doubts in that Google form also. So thanks for watching this video lecture. I hope this lecture would have been very much informative to you. Don't forget to subscribe this YouTube channel, and if you have your friends working on the field of neural networks and deep learning, then you can share these video lecture to them also. I hope these lectures would be informative to them also. So thanks for watching my lectures. Like this video. Thank you.